Let's look at the last question of question 1 from the sample problems. This is still the 2015 paper, and the link to the full paper is shared on the questions that were compiled by iCampSA, right? So here we are still continuing with exponents. This is a one-of-a-kind problem, right? But it's very important to understand these type of problems because they test your real understanding of exponents and sets, right? So let's look at what we have here. So here they are saying calculate the sum of digits of this number, right, of 2 raised to the power of 2015 times 5 raised to the power of 2019, right? But the first thing that we have to do is to understand what the question requires of us. So the question is saying we need to calculate the sum of digits, right? So what does that mean, right? The first thing that we have to do is to define what we mean by digits, right? So what are digits? So digits are the individual numbers from 0 to 9, right? So it's all your numbers from 0, 1, let's write them 0, 1, 2, 3, so on and so forth until 9, right? So when they say calculate the sum of digits, right, the best way we can do that is by looking at an example. So let's say for an example, right, they are saying we need to calculate the sum of digits of, let's say, 540 as an example, right? So what we are going to do, right, is we are going to look at 540, right? So 540, the digits of 540 is your 5, is your 4, and your 0, right? So we are going to try and add the individual numbers, which is 5, 4, and 0, that make up 540. So that is going to give us what? The sum of digits of 540. So this in simple term is going to be 5 plus 4 plus 0, which is going to be 9, right? So let's look at another example, right? So we can call this example 1. So let's say if we're required to calculate the sum of digits of 100. The sum of digits of 100. The sum of digits of 100 would have been 1 plus 0 plus 0, which was going to give you 1, right? Which was going to give you 1. So that's how we calculate the sum of digits, right? It's the individual numbers that make up that number, right? So what we mean by calculating the sum of digits, right? The sum of digits, it means that we look at the sum of individual numbers that make up that number, right? So this is what we need to understand, right? This is what we need to understand. So now let's look at the problem, right? So let's look at the problem right now, the problem at hand, right? So we are given 2 raised to the power of 2015 times 2 raised to the power of 2019, right? So there's an approach to solving this problem or this type of problems, right? So the first thing that we are going to try and do is we are going to identify the number with the smallest exponent, right? So we are going to identify the number with the smallest exponent, right? That's the first thing that we are going to do, right? So the number with the smallest exponent is this one. This is the number with the smallest exponent, right? And the second thing that we are going to try and do is to rewrite the other number. So this should have been 5, right? We are going to rewrite the other number referring to this one in terms of the smallest exponent, right? So we are going to rewrite the other number in terms of the smallest exponent, right? So the other number referring to this one, right? So we are going to try and write so what we mean by that is we are going to try and write 5 raised to the power of 19, right, to have exponent 2015, right? So that's what we are going to try and do. This is what we have to try and do, right? Let's use a different color. This is what we have to do, right? This is what we have to do. So now let's look at the problem now at hand. So we still have 2 raised to the power of 2015 times 5. It's going to be 5 raised to the 2 power of 19. So what we meant was we still have 2 to the power of 2015 times, now we are going to write this as 2 raised to the power of 2015 times 5 raised to the power of 4, which is going to give us what? 2019. So this is the same thing as having, it's literally the same thing as having, right, a raised to the power of m times a raised to the power of n, right? It's the same thing as that, right? So now we continue, right? So we are going to group these numbers. So this is what we are going to try and do. We are going to try and group this number because they have the same exponent, right? So this is going to be into bracket 2 times 5 raised to the power of 2015 times 5 to the power of 4, right? So this part, right, this part okay, it's closing in. So this is the same as having a times b all raised to the power of what? all raised to the power of m. We can just call it m, right? So now let's continue to the next page, right? So it's going to be 2 times 5 raised to the power of 2015 times 5 raised to the power of 4, and this is going to be 10 raised to the power of 2015 times 5 raised to the power of 4, right? So I need you to realize what is happening here, right? So for an example, right, if you had 10 raised to the power of 1, this would have been 10. If you had 10 raised to the power of 2, it would have been 100. If you had 10 raised to the power of 3, it would have been 1000, right? So ideally, this means that 10 to the power of 2015, right, it means it's going to be equals to 1, right, and 2015 zeros, right? So it's going to be 1 0 0 0 0. It's going to be 1 zeros until the 2015 zeros, right? So when we continue with this, it means that we are going to have 1 0 0 0 0 0 0 until 2015, right, times 5 to the power of 4, right? It's going to be 1 0 0 0 0 0 0 0 times 5 to the power of 4 is 625, right? So here what we have is literally the same thing as, let's say, if we had 100 times 6, right, it would have been 600. So let's say, for example, right, if we want the sum of digits of 600, so let's say as an example, right, as an example, we want the sum of digits of let's say 100 or 1000 times 67, right? So how we would have approached this, or how we would have done this, was gonna be 6 7, right? So 1000 times 67, it was gonna be 67,000, right? And the sum of digits would have been 6 plus 7 plus 0 plus 0 plus 0, which would have been 6 plus 7, 6 plus 6 is 12, plus 1, it's 13, right? It's 13. So this would have been the sum, right? So we are going to do the same thing with this one, right? So coming back to our problem, it's going to be 1025 times 625. So this is the same thing as having 625 zeros until the last one, right? So the sum of digits now is going to be 6 plus 2 plus 5, right, which is going to be 11, 13. So this is your answer, right? So this is how you solve these problems, or these type of problems, right? This is how you solve these type of problems, right? So maybe a homework would be, let's see if we can find a homework, right? Let's say a homework. Let's give you a homework. Okay, what happened here? Oh, let's give you a homework, right? So let's say calculate the sum of digits of 2 to the power of 2011 times 5 to the power of 2007. Right, so this will be your homework. Right, so go and try this and apply the same rules. Right, so these are the rules. Right, so these are the important rules. Right, these are the important rules that you need to apply. So go and try it, and then let's see what answers you get. Right, so that brings us to the end of question 1. We're going to be moving to question 2. So let's see what question 2 has for us.